Hello guys, this get lecture of engineering mathematics on topic Cauchy's linear equation is brought to you by lecturesforfree.com. Hey guys, this is the 10th part of differential equation series. If you haven't seen my earlier lecture, then I will recommend you to watch that also. Okay guys, so let's start. In previous lectures, we have solved the questions where the linear equation have some constant coefficients. Okay, we have solved the questions where the derivative coefficients are constant in linear equation, but there are other equations like Lagrange's linear equation, Cauchy's linear equation, where the coefficients of derivatives are not constants but the function of x. Okay, so to solve that type of question, we have to convert that type of equations to the equations where the coefficients are constant. Coefficients means derivatives coefficients are constant. Okay, so there are basically uh, two types of equation, linear equations: Cauchy's linear equation and Lagrange's linear equation. In this lecture, we will see about Cauchy's linear equation, and we will see some sample questions of this topic. For more sample solved questions, you can download my handwritten notes from my website lecturesforfree.com. Okay, so let's start the lecture. Okay guys, let's see this equation. In this equation, the coefficients of derivatives, means the coefficient of d to the power d n y upon dxn is x to the power n. Similarly here, coefficients of derivatives some function of x. Okay, it is not the constant only, but it is some function of x also. Okay, so to eliminate this function of x, we will make two assumptions so that we can convert this equation. This equation is standard form of Cauchy's linear equation. Okay, so we can convert Cauchy's linear equation to the equation with we can say linear equation with constant coefficients. Okay, to convert that, we have to make two assumptions here. We have to make two assumptions. Our first assumption is your x is equal to e to the power t, and our second assumption is your capital D is equal to d upon dt. Okay, let's concentrate here. Here it is a small x, not the capital X. Here capital X is representing the function of x. Okay, so here we are assuming small x is equal to e to the power t, and our second assumption is capital D is equal to d upon dt. Means we are trying to change this equation into the equation where our independent variable will be t. Okay, means here the equation is like dy upon dx d square y upon dx square. So we want to convert it like d upon dt d square y upon dt square. Means we are changing the independent variable. Means here it is x, we are changing it into the t by making these assumptions. Okay, so this equation will be converted into the d by dt equations. Okay, in that equation we will only have the constant coefficients. We will not get any function of x or function of t. Okay, so if we have made this assumption, then we can put our equation like this. If in term like this is present, dy by dx, we can replace it with dy upon dt. Okay, and if our term is like x square d square y upon dx square, then we can replace it like here you can write like d. Okay, dy. Okay, we can replace it like d into d minus 1 into y, and if our equation have term like x cube d cube y upon dx cube, so we can replace it d minus 1 d minus 2 into y. Similarly, higher order terms we can replace with d. Okay, so now our equation will be converted into the equation of constant coefficient. We will not get any function like this. Okay, so let's understand it by one example. Okay, let's see one question. Our question is, let's suppose solve x square d square y upon x square d square y upon dx square plus minus 4x dy upon dx plus 6y is equal to x square. Okay, so now here we can see here function of x is like this, here function of x. So this is like a Cauchy's linear equation. So to convert it into the equation of constant coefficient, we have to make two assumptions. Our first assumption is we are assuming x is equal to e to the power t. Okay, and our second assumption is your capital D is equal to d upon dt. Okay, and to convert this, now we can replace x dy upon dx is equal to dy, and we can replace x square d square y upon dx square is equal to d into d minus 1 into y. Okay, so now how you are getting dx equal to like this, y x square equal to like this, we can prove it, but I think for gate point of view we don't need to go in this how we are getting like this, but your concentration is like to solve the questions. So okay, we are not here to prove any theorem or any. Okay, we are going to solve this equation. Okay, so let's put x dy by dx equal to dy and x square d square y upon dx square equal to this. Okay, so our equation will be d into d minus 1 y minus 4 dy plus 6y is equal to e to the power t, and x square is there, so e to the power t square. Okay, so we will get we will solve like this, d square minus d minus 4d plus 6, and here y is out and e to the power 2t. Okay, so we will get it like d square minus 5d plus 6 into y is equal to e to the power 2t. Okay, so now it's like a function of d into y is equal to function of t. Okay, let's write it some function of t like this. Okay, so we can solve it by our methods that we have seen in earlier lectures. Okay, so to find the complete solution, we have to find the complete solution means y, we have to find the complementary function and particular integral. So to get the complementary function, how we will get it from auxiliary equation. Our auxiliary equation will be function of d equal to 0. So let's do our function of d means d square minus 5d plus 6 is equal to 0. From there, let's get the root of this. Root of this will be d minus 3 and it will be d minus 2 equal to 0. Then you will get root of this equation will be d equal to 3 and d equal to 2. So we got these two roots. So from these two roots we can get the complementary function. Our complementary function equal to, we know when we are getting two different real roots, then we can write complementary function like c1 e to the power 3x plus c2 e to the power 2x. Okay, if you are not getting about complementary function, then I will recommend you to watch my earlier lecture that is about complementary function. Okay, so there you will get how we are getting like this. Okay, so this is your complementary function. Now let's solve it for particular integral. So particular integral will be like 1 upon fd, and here capital X. Okay, you can write like capital X also, where capital X is representing your e to the power 2t. Okay, so e to the power 2t. So you can write like 1 upon d square minus 5d plus 6, and here e to the power 2t. Okay, so for particular integral we have seen many cases, case 1 to 5. So it is like a case 1 where we are getting e to the power ax and a function of d. So in that case we have seen we have to replace d with our value of a. Here a is your 2. Okay, a is 2. So in this function of d we have to replace d with 2. Okay, so when you will replace d with 2, then what you will see here, d square means 4 plus 6 means 10. Okay, plus 4 plus 6 means 10, and here minus 5 into 2 means 10, means you will get 0. You will get 0. Okay, if you will put 2 in your d, then you will get 0. Okay, so you cannot put 2. So for these type of cases you have to differentiate your function of d. You have to differentiate it. Okay, this numerator function of d, and you have to multiply here with your independent variable, like here it's a t. Okay, here it's a t, not x. So you have to multiply with your independent variable, means t, then differentiate it, then write like that. Okay, so you can write it like t, multiply with t, then differentiate it, then you will get 2d minus 5. Okay, plus 6 will be 0, then constant. Okay, and here you will get e to the power 2t. Now to solve this, you have to again put a in place of d. So here a is your 2, and if you will put 2 in d, then you will get 2 to the 4 minus 5 means minus 1. Okay, so you are not getting 0, means you can put it. So you will get like t minus 1. Yeah, here you will get minus 1. If you will put d is equal to 2, then you will get here minus 1. Okay, and e to the power 2t. So finally you got your particular integral. Your particular integral will be minus t into e to the power 2t. Okay, so now you got your complementary function, you got your particular integral. So you can write your complete solution. Complete solution means y is equal to complementary function plus particular integral. So you will get y is equal to c1 e to the power 3x plus c2 e to the power 2x. Okay, y1 is equal to c1 e to the power 3x plus c2 e to the power 2x plus particular integral. Particular integral is your this, so better write it minus t e to the power 2t. Okay, so you got answer this, but here you have to see, okay, we have done one mistake here. What mistake? Here you will not get x, because this is now you are solving the function. Okay, so in this function is about y and t. Okay, y and t. So here we have written x, but here it will be t, because in this case our equation is converted into y and t, where y is your dependent variable and t is your independent variable. So here we have to write t. Okay, here we have to write t, and so here we will get like this 3t 2t. But our final question, our main question was on y and x. Main question was belong to y and x, but we got the solution on y and t. Okay, so we have to convert this into the equation of y and x. Okay, so to convert it into the form of y is equal to some function of x, we have to put the value of t in form of x. So what will be value of t in form of x? We can get it from here. Okay, we have made the assumptions like x is equal to the power t. So here we can write t is equal to log x. We can write like this. Okay, we can write like this. So now let's replace the t. Let's replace the t with log x. So you will get y is equal to c1 e to the power 3 log or ln. Okay, it's a base e only. Okay, x plus c2 e to the power 2 ln x minus t. T means log x e to the power 2 log x. Okay, so we can again simplify it like y is equal to c1 e to the power log, we can write it like x cube. Okay, this will come in power plus c2 e to the power log x square. Okay, plus minus, what is here, let's see, minus log x e to the power x square. So we can write it like minus log x into e to the power log x square. Okay, so we can write it like x c1 x cube. Okay, we can write it x cube because here here base is also e. Okay, here e, here base is also e. So we can write it like this plus c2. We can write it like x square because here it is e, here base is e. Similarly, we can write here x and here e base e. So we can write it like x square. So this will be your final answer. Okay. So thank you guys for watching this lecture, and like my channel, and you can download my notes. You can ask me question on my website lecturesforfree.com. Thank you so much.